Oh, I can just hear the anti-vaxxers now. You're not putting any monkey virus into me. Ah. Hi, I'm Wendy. I'm a nurse, and I wanted to do a deep dive today into one of the most promising vaccine out of the 160 vaccines that are currently under trial. And if you hear a few clangs and bangs, I've got some work going on in the house that I'll be able to show you perhaps in the next week or two. The progress of what's going on here. So this vaccine, it's actually so promising that the Australian government has signed a letter of intent to obtain the patent to manufacture it here in Australia. And they've done this because other countries have stockpiled essential medicines, leaving the rest of the world to flounder without supply. Other countries have bumped up their manufacturing prices and leaving poorer countries without the capacity to buy essential medicines. So I think it's actually quite prudent that we manufacture here in Australia. Now, the Prime Minister is on record saying numerous times,
whoever finds this vaccine must share it. Any country that were to find this vaccine and not make it available around the world without restraint, I think would be judged terribly by history. And that's certainly Australia's view, and we'll continue to advocate that view in every conversation we have, as I certainly have.
So at present there's about 160-ish vaccines in the trial process. Now, some are further along than others, some are still in the preclinical stages. So there's 3 phases of clinical trials. So there's the preclinical stage, which is where they test things in test tubes and those sorts of things. Then it gets on to the clinical phases where they start testing it on people. So the first phase looks at whether it's safe and whether it's effective in a very small group of people. The second phase looks at a larger group, and with many of the COVID trials, they've actually grouped phase 1 and phase 2 together to try and shorten the amount of time, but without sacrificing safety. Now, phase 3 looks at longer term efficiency and effectiveness and safety in thousands of participants. And phase 4 is done after the rollout of the drug or the vaccine, and they look at longer term impacts of using this. So in order to know where to start, they actually have to work out how the virus behaves. How does it get into the cell? How does it multiply? So with Sars Cov2, and I'm using that instead of COVID-19, Sars Cov2 is the name of the virus. The disease that it gives you is COVID-19. So if you get Sars Cov2, you will get a fever, runny nose, shortness of breath. Those symptoms are COVID-19. So with Sars Cov2, first it has to attach to the ACE2 receptor. Then an enzyme has to clear the ACE2 receptor. Now, this enzyme is called TMPRSS2, and I've spoken about TMPRSS2 before, and I'll put a card up to so that you can link to that one. In fact, no, I might just link it at the end of the video. Now, what this TMPRSS2 was, it wipes any ability for the ACE2 receptor to read anything foreign, and so it basically wipes its ability to do its immune job. And so in this way we call this a COVID helper enzyme. Now, it's also really prevalent in men who are bald or who have a family history of male pattern baldness. So now it's in the cell. Then it has to copy itself, and this is a twofold process. First, it has to replicate the virus, and it hijacks part of the actual guts of the cell, so the endoplasmic reticulum and the Golgi bodies. And it hijacks these to do the replication for it. And so once it's actually replicated itself, it then has to reproduce the spikes and the capsule and join it all together, and then it has to mature back into a an adult virus, I suppose, and then it has to exit the cell. Now, each of these steps are vital if the virus is going to replicate and go on and infect other cells. And if we can interrupt any of these steps, then the virus can't replicate and it can't go on to infect the body. And this is what all of these 160 trials are trying to work out. What part in this process of virus replication can we interrupt to stop the virus moving on? So the vaccine that I want to look at is currently in phase 3 trials at Oxford University, and they've partnered with AstraZeneca, and AstraZeneca are going to do the manufacture. And it's in fact the letter of intent we have with AstraZeneca for us to be able to take the patent once they've proven efficiency and safety. So before I get on to the monkey bit, we need to understand herd immunity. So in order for a vaccine to give a population protection for Sars Cov2, it needs to actually inoculate between 50 and 83% of the population. And so if we've got enough people vaccinated, then that places even more distance between the person who's infected and the next person who is capable of being infected. Now, we call this herd immunity, and each bacteria and each virus has different levels of the population that need to be vaccinated in order for herd immunity to be reached. So whooping cough needs 92% to be vaccinated in order to achieve herd immunity. Mumps needs 75%, influenza needs 44%. But to compare, measles needs 95% vaccination in order to achieve that herd immunity. So our Chief Health Officer gave a really good example. He said, if you've got in a room a person with measles and a person with COVID-19, and you walk into the room and then some 10 minutes later walk back out of the room, you will have measles. That's how infectious measles is. You can walk into a room, take your first breath and walk out of the room and you will have measles. But with Sars Cov2, it's a little bit trickier. So it depends on whether the person's been coughing and spluttering into the room or whether they've just been sleeping and breathing easily. But by and large, what we say is that if you have been in a room for 2 hours with somebody with Sars Cov2, you are likely to be infected. Now, that's very different to the 10 minutes with measles. So how are they actually planning to interrupt this viral replication process? So I'll show you the list of the 160 vaccines that are currently on trial. And they list the different types of vaccine that it's going to be. This one is a non-replicating viral vector vaccine. So what they've done, and yes, they're using a monkey virus, or it's not necessarily a monkey virus, but it's a virus that is really similar to the one that causes us to have tonsillitis or conjunctivitis. So we're really familiar with this particular virus. But the cousin to this virus normally gives the same kind of things to chimpanzees, but we don't get this virus. So our immune system actually needs to be naive to whatever we put in it, so that it goes, oh, I don't know what you are, I'm going to mount an immune response. If they used the current adenovirus, and that's the name of the type of virus that we're using, if they used the human adenovirus, we'd go, we already know what to do with you, and nothing would happen. So in using the adenovirus that is particular to chimpanzees, we haven't had any exposure to it, so we're going to mount an immune response. So pardon with the banging. And what's really clever about this is that they've been able to identify which part of this adenovirus is the replicating part. Which bit do we need to switch off so that this virus doesn't run rampant in the body? So they've switched off its ability to replicate. So it's only going to be what's put in the body that stays in the body. And then what they've done is they've taken a piece of the Sars Cov2 virus. Now it's a strand of RNA, which is a chain of proteins, and they've taken a little bit of it so that our body can recognise it and work out that we need to build an immune response, and they've slotted it into the adenovirus. So then when they inject this into our system, the body goes, I don't know what this adenovirus is, and there's another little bit in there as well. We're going to treat it as one. And so if we then breathe in some SARS-CoV-2, this tiny little piece that our immune system already recognises is going to be present in the SARS-CoV-2, the full virus that we breathe in, and our body's going to go, there's something that we need to fight. And it will fight it, it will automatically recognise and fight it before it can get a foothold. And this is the trouble, our body's not recognising this virus until it's got a foothold, and then our immune system really struggles to fight it. Now, yes, I hear you say, but you're giving me a piece of the SARS-CoV-2 virus. Well, I liken it to an alligator handbag. So yes, you've got a piece of the alligator. Yes, it looks like a piece of the alligator, but it's not going to kill you. Well, unless you get hit over the head with it. But it's the same. All you're doing is delivering the alligator handbag. You're not delivering a live alligator. So this vaccine, it's been shown to be effective in a small number of people. We're rolling it out, or they're rolling it out in South Africa and South America, Brazil, I believe, because it needs to cover people of colour. It needs to cover people in different geographic areas, different climates. There's no point testing it on white Caucasians who are in their 30s and relatively healthy. It's got to be tested across the spectrum. So I'm really holding all hopes out for this particular vaccine, and once it's rolled out and it's ready for the general population, I'm going to put my hand up for it. I can't see that there's going to be any long-term effects. And in fact, I really don't think that there's going to be any short-term effects with perhaps, a bit of a sore arm when they put it in. And most people just get a little bit of a sore arm when they give a vaccine. So I hope you found this a little bit informative. I hope this has debunked some of the myths around what's happening with the vaccines. I'll link all of the bits and pieces down in the description below, so you can actually go and have a sticky beak at all the different trials, and you can click on the links in the trials. It's really quite fascinating what they can do. If you've got any questions, please pop them in the comments below, and I do my level best to get back to comments as soon as I can. Please stay safe, stay at home, wear a mask when you're out, and I will see you in the next video. Thanks for watching.